8.1 Properties of tangents to a circle. Before we introduce the tangents, as well as their properties, let's review some basic geometry concepts. The first one is Pythagoras theorem. The Pythagoras theorem only exists in the right triangles. This theorem talks about the relationship among three sides of a right triangle. C squared equals A squared plus B squared. C is always the hypotenuse. A and B are the other two sides on both sides of the 90 degrees. So we can say in this one, we let this side be A and this side be B. If we want to find the unknown side length, which is the hypotenuse here, we can use the Pythagoras theorem to form an equation for us. So C squared equals A squared plus B squared. C squared equals, I know the A value. A value is 3. So I plug 3 in for A. So I will get 3 squared plus 6 is for B. 6 squared. 3 squared equals 3 times 3. It's 9. 6 squared is 6 times 6. It's 36. Then C squared equals 9 plus 36. This one is 45. But we don't need a C squared. We want to look for C. C squared to C, we need to take the square root. You can use your calculator to find the square root of 45. It's around 6.71 units long. Let's look at the second case. In this case, I know the hypotenuse. I miss one side next to the 90 degrees angles. So I let this missing side be A. I need to look for this missing side A. And this side is B. So based on the Pythagoras theorem, I will have C squared equals A squared plus B squared. And my C value is 20. So I use 20 to replace C. The A value is the missing value. And the B value is 15 squared. 20 squared equals 20 times 20. This one is 400 equals A squared plus 15 squared is 225. If I want to find A squared, I subtract 225 from both sides. So I will get 400 minus 225. This one is for A squared. So A squared equals 175. I need to find A at the end. So the A equals the square root of 175. So this one, if you calculate this one, if you use your scientific calculator to help you find this value, it's about 13.23 centimeters long. So the second review is, in any triangle, the sum of three interior angles always add up to 180 degrees. Based on this fact, let's find the missing angle in both of these two triangles. I know this angle is 29 degrees. This angle is 33 degrees. I want to find the missing angle B. So since these three angles add up to 180 degrees, if I want to find this missing angle B, I can use 180 degrees. Take away 33 degrees. The remaining value is the missing angle value. So 180 degrees minus 29 minus 33 degrees, the missing angle is 118 degrees. Let's use the same fact to find the missing angle in this triangle. If I know this angle is 26 degrees and this one is 45 degrees, the missing angle equals 180 degrees minus 45 degrees minus 26 degrees. So the missing angle has the measure of 109 degrees. Let's look at some components of our circle. There are some old components that we have already learned before. There are also some new components of a circle. The first one is, if I connect the center of a circle with any point on the circle, this line segment is called the radius. If I connect any point on the circle with another point on the circle, as long as this one passes through the center of the circle, this line segment is called the diameter. If I connect any point on the circle with another point on the circle, and this one does not have to pass through the center of the circle, this one will be called a chord. I have another special line which is not in the circle. It's outside of the circle. It only touches the circle at one point. Like this kind of line, we call it tangent. Just like you have a bicycle standing on the ground, you will see each wheel touches the ground at one point. So let's look at this one. Here I have a circle. A line that intersects a circle at only one point is a tangent to the circle. Only one point. The point where the tangent intersects the circle is called the point of tangency. So this only point where the line touches the circle is called the point of tangency. So we have a very important property regarding the tangent and the radius. A tangent to a circle is perpendicular to the radius at the point of tangency. This property tells me if I connect the center with the point of tangency, this OP is perpendicular to the tangent AAB. This one means angle APO. So if we use 3 alphabets to represent an angle, you look at the angle in this way. Starting from A, P ends up with O. So the angle is this one. So this one is the same as angle BPO. So the angle is here. Both of them are 90 degrees. So right now we need to apply this property to solve some questions. Let's look at the first example. Determine the measure of an angle in a triangle. Point O is the center of the circle. AB is tangent to the circle. You don't have to graph the entire tangent. You can just show a part of the tangent. From one point to the point of tangency. If you see AB is a tangent, you should realize right away OA, which is connected by the center of the circle and the point of tangency. So this one must be a right angle. OA is perpendicular to AB based on the property we just learned. So this one is 90 degrees. And we know this angle AOB means this angle O is 63 degrees. We need to determine the measure of angle OBA. Angle OBA means this angle B. So if we want to find this angle OBA, we know 3 angles in a triangle add up to 180 degrees. So I use 180 degrees minus 90 minus 63 degrees. So I will get this angle in the right triangle is 27 degrees. Let's apply the property to example 2. Using the Pythagorean theorem in a circle. Point O is the center of the circle and CD is the tangent to the circle. So you need to realize this one is 90 degrees. OC is connected by the center of the circle. C is the point of tangency. So OC must be perpendicular to the tangent, CD. So right now I have a right triangle. This triangle, OCD, is a right triangle. And I have the hypotenuse C equals 20 centimeters. This side is the missing side that we need to look for. And this side is given, which is 15 centimeters. I let the side be B. So based on the Pythagorean theorem, I will have C squared equals A squared plus B squared. C is 20 centimeters. I replace the C with 20. A squared is the missing side squared. B is 15 squared. So 20 squared is 400 equals A squared plus 225. So A squared equals 400 minus 225. A squared equals 175. If we want to find A, we need to square root both sides. So the square root of 175 is around 13.23 centimeters. So this question is exactly the same as what we find for this missing side in this right triangle. Right now, let's look at the last example. Find the length of side A and angle Y degrees. So you will see PT is the tangent, P is the point of tangency, O is the center. If you join these 2 points up, OP must be perpendicular to the tangent PT. So this one is 90 degrees. So Y, this angle equals 180 degrees minus 90 degrees minus 54 degrees. This one is 36 degrees. Let's look for the missing side A. This missing side A, I will let the side be B and the hypotenuse is C. C squared equals A squared plus B squared. C is 12. This is 12 squared equals a squared plus b. b is 7, so 7 squared. So this one is 144. A squared plus 7 squared, 7 times 7 is 49. So a squared equals 144 minus 49. A squared equals 95. If I want to find a, I need to take the square root of 95. So the square root of 95 is around 9.75. Therefore, the missing length, which is the length of PT, is around 9.75 units long.